Yes, welcome to DC Economics. Today is intermediate macroeconomics. So we are going to begin by looking the utility, maximization and choice. So in this chapter, we are going to look on consumers, on how they make consumption decision given their preferences and budget constraint. So utility, actually, as you know, the budget constraint is realized. Every consumer make purchases in the market for goods and services. So what is utility, by the way? Utility, this is the satisfaction obtained by individual after consuming goods or services. Somebody might ask you, what is about budget constraint? In a simple manner, the budget constraints represents all the combinations of goods and services that consumers may purchase given their current price within his or her given income. Actually, when you go to the shop and ask you 2 bottles of soda, you can purchase what it actually lies may fill your anchor in one way or another. So under this, actual, the consumer theory uses the concepts of budget constraints and a preference map as a tool to examine the parameters of consumer choices. So, for example, let's serialize the following graphs over here. So, when we sketch this graph, we have the left-hand side that is good y, and we have also good x, whereby a is 0.5 and b is 7.0. So, consumer can make a purchases on 2 goods, maybe apple and orange, whereby we have 200, we have 100 in the left-hand side, and the graph, the lines that cut across the left and the bottom x-axis is the budget constraint, as you can observe. So actually the consumer theory uses the concept of budget constraint and a preference map as a tool to examine the parameters of consumer choices. So for example, we can write the budget line, or we can write the budget constraint as the price of x times quantity of x plus price of y times quantity of y, which is equal to income, where px is the price of x and py the price of y. So in economics, preference is an order that an agent gives to an alternative based on a relative utility process by which it results in an optimal choice, whether real or theoretical. So actual the relative utility of a process which results in an optimal choice, whether that is real or theoretical, as I told you. So preferences are evaluations concerns matters of value, typically in relation to practical reasoning. But also we may define preference is like one thing or one person better than others, where you prefer one and ignore one. You prefer one and ignore one. That's one be better than other. That is a preference. For example, of preference is when you like more watermelon than orange, or where you prefer taking out motorcycle than a car. Let's look now on a graphical introduction to the budget constraint and utility maximization. You need to understand that normally a person will maximize the utility subject to their budget constraint, that they will do the best that they can give amount of money that they have to spend and the price that they face. So a graphical introduction to budget constraint actually relies on where the utility is maximized, where the indifference curve cut across the budget line. So normally a person will maximize the utility subject to the budget constraint, that they will do the best that they can give the amount of money that they have to spend and the price that they face. Now, if a person has income I and consumes good x and y, if a person has income I and consumes good x and y, and the price of these goods are price of x and price of y, actually this can be written as the budget constraint to price of x times x plus price of y times quantity of y that is less than or equal than income. Now for example, let's look at another example over here. If a person has income that is $120 and the price of x is $10 per unit and the price of y is $5 per unit, then the budget constant can be written as, we take out the price of x times quantity of x plus price of y times quantity of y is less than or equal than income, whereby we plug in the 10x plus 5y is less than or equals than 120, as you can observe. Now in terms of graph, it's look like you take out a graph showing the utility maximizing point on the budget line, whereby we draw the graph on the left hand side. We have in the left hand side, whereby we have the output, we have the quantity of y that is I over py, and at the x-axis we have the quantity of x. So the maximization of utility actual takes on the forms of where the utility are cut across the budget line. The indifference curve, the slope of indifference curve is normally equal to the slope of the budget line. So the highest utility U3 represent out the high satisfaction after consumer attaining a certain good and services. Utility 2 represent the lower utility satisfaction, as you can observe. So and the xy and x star as well is utility maximizing band of goods given the indicated preferences, given the indicated preference and the budget constraint. For example, let's imagine that a person faces a price of x which is $20 and the price of $30, and is as utility functions that is utility of x comma y that is x square times y. So the slope of our budget line would be, now we take the data given that is equal to price of x which is equal to $20, the price of y which is equal to $30, and the utility function that is x comma y is equal to x square times y. So from the data given now, the slope can be taken by taking the marginal rate of substitution of x comma y brackets is equal to marginal utility of x over marginal utility of y. We apply the derivative change in respect of x, that is 2xy, the derivative change in respect of y, that is x square, and divide by price of x and price of y, we'll obtain 2 over 3. So when we cancel, we drop up the figure. Now this will give us 2 over 3 is equal to 2y over x. So at utility maximizing point, the quantity of x that she has will be equal to the 3 times the quantity of y that she has. So at utility maximizing point, the quantity of x that she has will be equal to the 3 times the quantity of y that she has. So actually, we do not know exactly how much of which she has without knowing her income or how much she has to spend. So let's come and analyze something to note in utility maximizations, how it occurs, or we actually tell the optimization point. Utility maximizations occur whereby the slope of indifference curve is equal to the slope of the budget line. So where the slope of indifference curve is equal to the slope of the budget line is where the by optimization point is reached. So but there are few exceptions. There are few exceptions that of the condition of optimization. Actual, it is not actual every time that maximization of points should occur where the indifference curve cut across the budget line. There are some few exceptions that go against the rule of optimization. The first one is corner solution. Corner solution is a special solution to urgent maximization problem in which the quantity of one of the arguments is maximized function is 0. So is when now the chooser is either unwilling or unable to make a trade-off between goods. So it may be that the indifference curve is always the steeper, always flatter than the budget line. Now, actually to understand here, in this case, the utility maximizing bundle is entirely composed of one good or the other. So this corner solution actually demonstrate out the graph to be in the difference form, apart from the condition of optimization. So actually, when you sketch the graph, you will come to realize that the consumption of good of x that's represent the indifference curve is going very flatter for the consumption of x and different from the consumption of y. So this is the graph actual you can observe here. In the left hand side we have the quantity of y that will take in the form of I over py, but when you sketch out the graph over there we have the indifference curve that shows the maximization and the lower indifference curve and the upper indifference curve. We have x, that is the quantity of x that is I over px, and where in the right hand side we have also the quantity of y. The consumer consume only commodity y or commodity x. As you can observe, we have y over py, we have y over px and the quantity of x. So the two graphs showing the indifference curve and the budget line in this situation where now the consumer chooses to consume either good x or only good y. Another factor, another exceptions for optimization rule is about perfect substitutes. Actual, when you speak about the budget, when you speak about the perfect substitutes, now if two goods now a perfect substitute, then the indifference curve is straight line, and the analysis now is similar to that of exceptions. You can imagine yourself the two brands of gasoline that you consider to be identical. For the two brands have different prices, now you only consume the cheaper brand than the other being equal. So the one exception is when now the slope of the indifference curve, which is, remember, is a straight line, is the same as the slope of the budget line, also the straight line, in which case the price ratio is equal to the marginal rate of substitution, and any combination of two goods is utility maximizing. So under perfect substitutes, if two goods are perfect substitute, now the indifference curve will always go in the straight line, and actually this would actually realize the exceptions or the against laws of utility maximization. So the one expression is when the slope of the indifference curve, which is, remember, as a straight line, is the same as the slope of the budget line, also the straight line in which the case the price ratio is equal to the marginal rate of substitution and the combination of two goods is utility maximizing. Another exception is perfect complements. Now if two goods are perfect complements, then the utility maximizing outcome is to consume them in this appropriate ratio, now regardless of their relative price. So you will consume an equal number of left shoes and right shoes, and at any one time anyway you'll use the 4 times as many as times as you have automobiles. This diagram here demonstrates out the perfect complements. You can observe the budget line, the left hand side of the line of the graph, that is I over py, that is the quantity of y. We have also the bottom one that shows the quantity of x. So these diagrams looks like this. So we have the budget line cut across, we have the line of utility level, and we have the constant that shows the output and the price. We have the quantity of x, and we have y over py. So this graph showing a budget line and indifference curve for perfect complements. So after taking that, now let's go to the math behind utility maximization. So the math behind all this is as follows. You need to understand the goal here to apply the mathematics in utility maximization is to choose out the band of goods so as to maximize utility subject to the budget constraint. So this can be written as the maximization of utility. This can be written as a maximization of utility that is equal to utility bracket x1 times x2 is equal to xn, that is subject to I, our total income, that gives us price 1 x1 plus price 2 x2 plus price of pn times xn. We can demonstrate taking out income minus prices of p1 x1 or minus p2 x2 minus pn. So the langararian formula will be given as utility, that is x1 x2 minus xn plus lambda bracket p1 x1 plus p2 x2 plus pn xn. So the above stuff now can give out our langararian formula that we apply, that lambda is equal to 0. So we can write our langararian formula as L, that is equal to u plus lambda times budget line, whereby our lambda, that is marginal utility of income, is given by marginal utility of x over px and marginal utility of y over py. So in fact now the lambda has interpretation of being the marginal utility of income. Now it is the increase in the level of utility that will be achieved if the income were to increase by 1. Now let's go to an example. Imagine that the utility function is given by u, that is bracket xy is equal to 5xy square, px is equal to 2, price of y is equal to 8, and income is equal to 240. Now we require to set up the langararian, then to solve the optimal bundle, then to calculate the resulting level of utility, then to graph out the relevant curves, and then to calculate the marginal utility of income at the optimum. Now the solution will be as follows. So let's dot down our data given over here. We have the utility function that is given by utility function of xy is equal to 5xy square, then price of x is equal to 2 and price of y is equal to 8, and income is equal to 240. Now from langararian formula, that given utility plus lambda times budget line, whereby utility is equal to 5xy square and our budget line is pxx plus pyy. So let's plug in our price and our price of x and price of y. We will obtain the budget constraint, that is 240 minus 2x minus 8y. So from the langararian formula, u plus lambda bear times budget line, we plug in our value of utility function, then we times out the lambda over the budget line. So we differentiate dl over dx, that is given the equation 1, but also dl over dy, that gives an equation 2. So we differentiate of dl over lambda, that will give you 240 minus 2x minus 8y, that is the equation number 3. Now with this, actually we have set a set of the langararian formula. Part B, now we need to solve the optimal bundle. Now from dl dx, which is equal to 10xy minus 8 lambda, we take out the values of dl over dx, that gives out 5y square minus 2y. Now we set out our dl over dx is equal to 0. Then we make lambda the subject. We'll give you now negative 2 divided by those values over here. We'll obtain the equation 1. Now from dl dy, we do the same. We make lambda the subject. When we make out the lambda the subject, we obtain out the values of y. 8y lambda is equal to 0 minus 10xy. When we divide, we obtain out our lambda equation. That gives you 5 over 4xy. Now we equate the two equations for lambda. That will give you lambda is equal to lambda. Then we take out 5 over 4xy is equal to 5y square over 2. We divide by 5 over 4 both sides. Then we obtain out the values of x, y is equal to 2y. Let's choose to make out x is a subject. That will give you x is equal to 2y. Now take our x is equal to 2y, then so when you take out and you plug in, you'll obtain the values of y and the value of x. So this will be 4y times 8y is equal to 240. That will give you 12y is equal to 240. Divide by 12 both sides, our y is equal to 20. Now from x is equal to y, we plug in the same values. That will give you x is equal to 2 times 20. That will give you x is equal to 40. Or we may plug into the budget line. That will give you the same answer. That's y is equal to, that will give you the same answer, that is equal to y is equal to 20. So the consumption bundle now will be x is equal to 40 and y is equal to 20. Now let's go to part 3, that is to find the resulting level of utility. We take the utility function, utility xy is equal to 5xy raised power of 2. Then utility function, we plug in the value of x, that is 40 and 20, will give you 8,000. Now let's go to the last question, that is to graph or to demonstrate the graph. Our graph will be equals to the resulting level of utility, as you can observe. take out the resulting level of utility, that is equal to 8,000, where the maximization for utility, the difference curve cut across the budget line. Here we have 14, here we have 20. The quantity of y, as you've observed. Then we find out the marginal utility of income. The marginal utility of income is equal to marginal utility of x over px, that is equal to 5y squared over 2. Divide, plug in the value for x and y, it will give you marginal utility of income is equal to 10,000. The same applies to the y, it will give you 10,000. So that is how we actually solve when they apply the equation. So the marginal utility of income would be that one. Thank you and welcome to DC Economics. Bye.